Well, it's absolutely an honor to be here and to do anything that Mitch and Eric asked me to do. I just, try to say yes whenever I can and then get to have wonderful opportunities like this. My goal today is just to give you a little primer on integrative data analysis because it's before 9 and you're still having your coffee. So we'll give you a little bit of time to get the neurons firing before you are on to have the conversations yourself. So I'm going to take some time to present a little bit about what was in the flipped keynote that I did, but a little bit about some tools that might be helpful for starting discussions just this morning. So let me just do that kind of briefly. And I just want to shout out to my colleagues here, Patrick Kern and Dan Bauer. We've been doing this work together for a while, and they're up in Baltimore now at SMEP trying to tell other people about it. So you get me this morning. So this is just a figure just to remind you the big picture of what integrative data analysis is. And that is really the pooling of data where we're going to do analysis at the level of the raw data or the individual participants. And there are a lot of data pooling techniques out there right now. The main thing that makes this a bit different than meta-analysis, which is what most people would be familiar with, is that often with meta-analysis we're working with summary statistics. Although there are newer techniques that try to get at the individual, there's a lot more emphasis on measurement and harmonization in IDA than there is in meta-analysis. And so in a nutshell, those are some of the differences that are there. What we like about this is that it allows us to answer questions with the pooled data set that you can't answer with the individual data sets. And this whole technique was born out of answering substantive questions. So we didn't go in and trying to methodologically figure out what kind of interesting things we could do. We went into it to try to answer some questions. And that's really where moving forward with this will come. So that's what's so exciting about having a group of substantive researchers take a look at this and say, how can this be helpful to us? So that's what it is. And apparently my slides are forwarding all by themselves, or I'm very, very much so wagging this around up here. The advantages are the ones that you had heard about. There are things like being able to have this more efficient use of resources. Anything that's secondary data analysis is going to let us move in quickly in some ways. Although the one thing I will say to anybody getting into this endeavor, it's not fast, right? Many people start secondary data analysis thinking, oh, I skipped that whole step of contacting and recruiting people, but now I have to learn somebody's idiosyncratic way of documenting their data set and finding out all the things people don't write down. So it takes some time, and I will just give you that caution as you get into it. One of the things that we find particularly helpful in using this type of technique is it lets us get at smaller sample size questions. There goes my crutch. That's why I'm sitting. No, I'm going to sit. So, for example, the initial studies that we were doing were trying to look at putting together different age groups so that we could look at a longer age span than we could in an individual study. This is also helpful for doing things like looking at rarer behaviors because you may not increase your prevalence rate when you put your data sets together, but you have more people, so you have a little bit more model stability when you're doing that. Clearly, people do this to increase their statistical power. But I think the other thing that's not really been realized is thinking about the issues of replication, and Eric was mentioning this earlier. Built directly into hypothesis testing and integrative data analysis are looking at the extent to which effects are replicating across studies. And indeed, there's some ability to look at why they may be or where they may not be replicating. And we can talk about that later if you like. Yeah, it's just forwarding on its own, so let it just roll. I talked a little bit about the typical steps in the talk that I gave you, and so what I would just say about this is implementing this is harder, of course, than reading it off the page. And I was just going to give you one kind of example of kind of how when I start a consult with a group, the types of conversations that we end up having and the information that people bring together to try to figure out feasibility, because this is what you're going to get ready to do a little bit of here in a moment. So let's see if I can do that. That's the wrong way. Now, everything's backwards when you sit down. All right, so here's an example of a feasibility analysis. And if you remember the steps, the things I say that we find most helpful is you start with a question. So most people want to start with the data. But often our data sets are large, and there are many ways of putting them together. And the work of making them all integrated is larger than what you may need to do to answer a particular question. So I encourage you to think about those particular questions as a starting point. And in this example, I'm working with a group, and this is going to be a little bit hypothetical so I don't give away their research designs. But we're interested in the central question about intergenerational transmission. So do parents in that first generation who have depressive disorders in adolescence and early adulthood, is that a pathway of that continuity of depression to seeing depression in the teenagers of their children, those G2s? And so there's not a lot of data out there that carries over assessments of generations in this way. And so one of the things that we might be able to do with integrative data analysis is bring together studies that allow us to answer this type of question. So what we know from this is we need designs that are going to give us information about the first generation and in adolescence, the early adulthood period of that first generation, and then the teenagers. And there are 3 core studies. We're going to say they're from Indiana, Arizona, and North Carolina because those are 3 places I've lived. Those are not the actual studies, but we've got them, and we're going to try to see if we can make them fit. And so these are the type of tools we use to try to see if we can bring data together around a question. And here's one. We know that we've got the 3 studies. We know we've got the 3 age periods that we might need to look at. And so I'm just going to start thinking about how each study fits into that, because often you're going to unpack the studies you're working with to put them together in sort of a different way than maybe the PI thought about it. So here I know that for my adolescent G1s, I've got assessments in Indiana when they're 10 to 13, in Arizona when they're 10 to 12, and in North Carolina, they got them a couple of times in adolescence, so I've got some choices there. I've got age ranges then for those same G1s when they're in early adulthood, and then I've got some assessments when the kids now are G2s later on. So that's kind of trying to map the designs out against one another before we even get to measures to see if we can cover what we need to cover. So I'm going to make my choices then to line this up based on whatever methodology is important to me. And in this case, a couple of things are important. I'd like the age ranges to be pretty comparable across studies. And I would also like the age ranges of the adolescents in G1s and G2s to be as comparable as possible, right? So we can try to line up those developmental periods. So I'm going to make some choices that cleans up the data and tells me where I'm going to go into those data sets to start looking for comparable measures. So now I have a design. And indeed, that's what integrative data analysis really is. It's a methodological design rather than a statistical technique. So I'm going to go in now and say, do I have the constructs? I'm not going to worry about having exactly the same measures because that's not required for IDA, but I got the constructs. Now I can go into the batteries a lot more easily and try to figure out how things are going to line up. And I find out that across these studies, and this lays onto an example of this, there are 4 key measures that are used to assess depression, and they have been modified in various ways. And this is not atypical. So we modify our standard measures all the time. And those tweaks make differences between our studies when we're trying to pool them, right? And we want to find where those are in our data so that we can make decisions about what we're going to harmonize and not. So here we've got measures A and B. We've got a B prime, which is measure B, but slightly different. So I'm trying to track all those differences so I'm going to be able to line up the studies and figure out which measures I'm going to use. So from here, I'm going to be able to figure out how to put together my data pool of items. And if you remember, there are really kind of 3 types of items that we're working with. Those items that are identical, so it's the same measure given the same way. And same is something we need to unpack a little bit because PIs often have the sense that, yeah, I just changed the directions a little bit. Or, yeah, that word doesn't work in the Midwest, so I just changed it a little bit. That's really not identical. But they can be measures that could be harmonized. So we've got our identical measures. We've got those that can be logically harmonized. That's sort of the eyeball lining up of things, using expert panels, various things to do that. And then we've got those unique items. And what's a little bit different about IDA versus things like item response theory and other ways of thinking about putting together harmonizing data is you keep your unique items. So we want to measure the construct as broadly as we can. We have fewer items to measure something like depression than we do to measure something like proficiency in algebra. So we're going to hold on to some of those items. And that's going to help us more clearly define the construct. So we'll put those together. What do you need? You need some common items that have either identical or a logically harmonized structure. And if you have ever tried to put together tables that look like this, where you're trying to say, okay, How are the directions looking across my studies? What do those response scales look like across the studies? And then what items do I think are getting at the same thing? I'm going to line those up. And when you do a table like this, most of us are going to at some point get this little pit in the bottom of our stomach that says, I think that's the same item. And hopefully you do. And hopefully that will motivate you to do the next step, which is to do the actual psychometric harmonization procedure. Because there are a number of people in the literature who are stopping right here. And some of the research that we're doing that's more on methodological development indicates that that thing in the pit of your stomach is right. Sometimes you're wrong when you make these assumptions about logical harmonization. But this is a step, and as you can see, this is probably pretty labor intensive for us. Information and Library Sciences, or SILS, is really working to have some more tools that will make this a little bit simpler and more streamlined for us. So there are exciting ways of thinking about those coming together, but we're not there yet. That psychometric harmonization that I was mentioning, we are using the tool of moderated nonlinear factor analysis. If you see Dan Bauer, tell him, still terrible acronym. We've got no good acronym. It's MNLFA. So that's what we've got. And Dan really came up with this approach. And what this approach is really doing is taking those strengths of IRT and CFA, confirmatory factor analysis, and item response theory, and putting them together. Sorry, it just really doesn't want to behave. We're interested in not just how many items you're endorsing, but what items. We're interested in how those items might behave differently depending on a set of covariates, one of which, not surprisingly, is study, right? Is it functioning differently across study? But it could also be gender. It could be age. This is a nice way of taking those developmental varying constructs into account and taking heterotypic continuity into account when we're scoring. Really, seriously, okay. And the goal here, and I'll just say this really loudly because this is probably the one thing that's most confusing, is that we're not in the end really worried about lining up all those items. We're worried about get factors that are comparable across studies. And that's really the key for IDA to work. And we're going to use missing data algorithms and those types of things to get there. Okay, so suggestions for starting your conversations. That was kind of like, remember these things, and here's a few ways that you can use them. My suggestions are to spend some time on those questions. The questions that you're not really able to answer in your own study that you could answer better if you could put different studies together. Because one of the things that doesn't work really well is to spend a couple of years putting these data sets together, and you've pored over the code books and you've tried to figure out how to use the R code, and you've got scores, and you've answered the same question everybody else answered, and you got the same answer. And now you're really struggling to publish it because what you really got is a fancy method for an old question. So I really encourage this time on thinking about what questions you're going to be able to get to and thinking about data sets in a way that they weren't originally probably designed to answer questions for. So that's one recommendation. And those types of questions that we found people are using this for to more effect are looking at subpopulations, rare behaviors, developmental age spans, those types of things that often we're limited in doing in our single studies. There are probably a lot more things that are going to come up for you guys as experts in your field, but those are the ones that I've seen. I'll thank you guys in a minute. Thinking carefully about the final models that you might end up as you're going into an IDA is important because you probably have some control variables that are going to be necessary. You also have to pull those out of your data sets and harmonize them. So thinking about not just your outcomes and your predictors, but what else you need is very helpful as you go in the first time. And finally, just plan to spend some time on the data management. I've sort of become convinced that the best way I can do a personality test for people is to say, hey, give me your code books. I don't think I've seen two code books that are put together the same way, sometimes from the same person. So it takes a while to do that. And, trainees, you're doing this a lot of kind of walking to somebody's lab and spending some time getting to know their data. Now you're going to do it for 5 data sets at the same time and try to figure what happened in 1995 that didn't get written down that accounts for those cases that seem to be missing randomly through the data set. So often this is very much a place where team science is important. Your best friend are going to be the data managers, whatever projects you're working with. The PIs don't know anything. So talking to those different data managers and creating a team to get there is important. But I really like people to go in with their eyes wide open here, because otherwise they were hoping for a quick research study that comes out of it, and it doesn't quite work that way if you have a lot of unpacking. But I think the fun part is what those questions are that you guys are going to have. This is my thank you slide to many folks, including Ken Schur, who's over here in the room and has been doing this with our team for a number of years. So I'm going to stop there and let you guys talk.
We have some time for some general questions for Andrea. Eric. Oh, thanks.
Blind spot.
Your slides were really helpful. I was thinking last night as I was reading it, what about when you have multiple informants and they don't converge? So if you got, when I was thinking about this, like with CBCLs and YSRs,
Yes.
would you want to put those into the same thing, or would you just want to use informant as a control variable, or how would you think about that issue?
Patrick says thank you right now because he's got an R&R in right now that is this question.
Okay.
And I think it sort of depends. Do you want to go for, as you would in any study, trying to get at the commonality of what's coming out of the different reporters? And if so, there's a trifactor model that's being applied in an IDA context to be able to do just that. In some ways, you're separating out those things of item variance, source variance, who's the reporter, and trying to get at the factor. So there's a technique that we've been using to do that, to get to this. Study is another source. You'll have to have enough coverage to do that. So if you're putting a lot of really small studies together, it'll be hard to do. But the other choice point is the one you're very familiar with, which is, in this study for this question, maybe it's better for me to go with a particular reporter. But across studies, you may not have that. In this trifactor method, you don't have to have the same sources across all studies, but you need to have some cross. So as you're thinking about things, if you have any variable that is completely confounded with study, so one study's got mom report, one study's dad report, one study's got kid report, there's nothing I can do to tell you the difference between reporter and study. There's nothing magic here. But if you've got a study who has all three reporters, and then you have studies who have some of those reporters, now you can link them so that you can do that integration. So I hope that gave a sense.
So you commented briefly this morning on missing data, and just wonder if you could say more about what do you do if your sources have very different approaches to managing missing data?
So the one thing that's different here is you're going to make all those decisions because you're going to work with the raw data. So I can't say strongly enough that team science approaches that have to do with how you're communicating with one another are critical here, because usually you're dealing not with team, but teams of teams who may have a tradition or a way that they want to handle missing data. So now that's a political question, and they're all intertwined. But in general, you're going back to having the raw data so you can make the same decision for how to handle missing data across your studies as you're pulling them. And you'll have missing data by design, you'll have missing data by attrition. There'll be a number of ways that missing data will come into play. And depending on the form of missing data, you may be using more than one approach to doing that. If you have panel data, it may be one approach. In the end, it's not that fancy. Once you harmonize data and get factor scores, it's business as usual, as if it was one big sample, but you're going to track study effects as you go through. So whatever you might do for a big sample for missing data would be applicable here.
Could you talk a little bit about the pros and cons of selecting a single time point to derive the factor scores and how that may or may not be problematic?
Yes.
That was very specific on my part.
No, that's, I think there are two things. One is in doing the psychometric modeling, we don't want to have a lot of nested data because there's usually a lot of complexity in your covariate structure. So you end up having one observation per participant. We don't usually take it based, like if you have longitudinal data on one wave, we'll randomly sample which of those we're going to use from participants so that we're looking at the whole stream. So if you want to know if you have age by study effects, you've got a developmental trend that's different across studies, you don't want to be looking at just at one wave because you've really not captured your data. So there are two issues. One is you don't really want to look at just one wave or time point when you're doing scoring, but you also need to pay attention to your nested structure. Did I get there?
Could you comment on the kind of boundaries of the methods that you could combine? So let's say you have a self-report and then you have an observational level of analysis, or you have a behavioral level of analysis that's tapping into the same construct, or a biological level of analysis. I mean, are there clear boundaries as to where you can and can't combine data?
That's a lovely R01. We've tried to play with this a little bit, and it's a bit like the source question for us. So if it's completely confounded with study, I don't think there's much that we can do. You can still harmonize it and analyze it. As you know, your software will run all kinds of inappropriate models for you. That's fine, and you'll get answers, and sometimes they get published. But what we really are worried about is pulling the study effects away from those different methods. So you have to have some studies that have more than one method. We're interested in seeing whether this trifactor model would be effective for that type of thing too. So it's not just reporter differences, but it's modality differences as well. We haven't really been able to run a lot of those models yet. So, our computer simulation studies where no one really filled anything out are happy with it. But seeing what that looks like in practice, I don't quite know yet. But I think that's the promise of a direction.
I was wondering if you had any advice to someone maybe putting together a grant and regarding like what reviewers might say. Are there certain concerns you hear, and what might they put in their application to allay concerns?
Yeah, that's a great question. I think the one that walks hand in hand with that is, how much of the IDA do I have to do before I submit the grant? And the answer is there's a lot about feasibility. We find that there are certain things that you have to say multiple times in your grant. There are some people, I think there's just like some disbelief or unfamiliarity, but the idea that you don't have to have identical measures for this technique to work has to be said about every 2 to 3 pages. And you need to sort of demonstrate that a little bit. So we often, for the grants that we've had that have been successful, we have to do a little bit of IDA analysis. We show a growth curve, or we show that we can put together something that's predictive at a very simple level, which is a lot of work. I mean, you basically need to do a pilot study to get it. So, and that pilot study is, can you actually put these data sets together? And in the long run, that's so helpful for you too, because one of the things that we do is, you've got the sample size that everybody tells you they have, and that's their highest sample size. That's not necessarily the sample size we have when we narrow it down to the question you want to ask. And you don't want to have a hole in the data somewhere that you didn't expect. So it protects you too. But those pilot analyses are critical. And I think the other thing that's very helpful, to have somebody who's done one before. Apparently, that's what the review panels are asking for. But I think also making sure that you've got time and expertise on the data management side, so there's some buy-in from the projects that are coming. Those are the things that I'm seeing mostly right now. But basically, having some show of the data is important.
I'd be curious about these study effects of which you speak. It seems like a category that captures all the cohort effects or whatever, but also I would bet if you've looked at more than one study, you start to develop hypotheses about what might drive some differences.
So this is an interesting thing for a field, right? So IDA is really about study effects or nuisance effects. I want them to go away. I don't care where they're coming from. I want them to go away so I can get at a pooled sample. But the studies in your field have reputations. And there have been literature reviews written that have said, I think this might happen because there's this gender bias, or there's this way that people have been recruited into the study, so we're getting these effects. So we have a lot of these hypotheses. If you have enough studies with variance in them, you can see if your study effects go away if you control for those things. So instead of doing a whole nother study to try to see if you can explain inconsistent effects in the literature, which is usually very hard to do, you can try to get back to the source of where the study effects might be coming from. We haven't done this, and I think the politics are as difficult as the analyses on this. But it has a lot to do with how we talk about our studies and how we think about their strengths and weaknesses and how we want to unpack them, and how we want to be very upfront with all of our PIs as we're working with their data as we move forward. We're all very sensitive to data sets that we've cultivated over the years, and having a narrative that comes out of the other direction against us would be weird. And I've certainly seen teams get into struggles around some of that. So I don't know which of those sides you're thinking of when you're asking this, but I think they're both equally important to be aware of as you're going in. But I do think that there's a lot of power in trying to understand where study effects come from, and I haven't really seen it applied that way yet.
Okay, if there are no other questions, thank you very much to Andrea Hussong for here's what we're going to do. For the next few minutes, we're going to have some conversations about what are some questions that would be our top priority questions that we could ask if we used an IDA approach, as Andrea is suggesting that we kind of start with. And then maybe we might even get to the point of just wondering, are there people that happen to be sitting around the table who might have data that could be combined with other data sets if we wanted to address those questions? So what I'd like to ask for folks to do is to think about what you would like to talk about for the next few minutes, and we're going to divide the room just a little bit. If you would like to talk about questions that might be particularly ripe for an IDA approach related to depression, I'll ask you to temporarily kind of go and sit on this side of the room. If you have data sets and or questions you'd like to ask about IDA for bipolar, if you can move to the center of the room, and there might be a couple different tables, you can put them together, you can keep them apart, whatever. And if for those that would like to talk about suicide, we're going to sit on this side of the room. And we'll do that for about just about 30 minutes or so before we take a break. So please rise. And thanks. Thank you so much.